Welcome back to another episode. Today we are going to be using I2C again, but this time we're using off-the-shelf controllers. I have two different controllers here. This is the nunchuck and this is the classic controller. Both of them are made for Wii gaming console, and these turn out to be using I2C bus. So there's like the outputs over here. They have data line, clock line, standard I2C. If you're familiar with I2C. Now in a previous episode we have used up this really low cost OLED display that is I2C as well. So I thought this would be a really nice episode to show how you can use multiple devices on the I2C bus and then benefit from these very cheap, very inexpensive controllers. You can pick these up on like eBay for very, very cheap, like $5. So this has an accelerometer in it, so you can detect motion. And this is an analog knob over here. This has a couple analog knobs and a bunch of buttons that you can use to control whatever you need, maybe a robot. So in this demo, I'll show you really quick what I have. I am not doing anything with the other buttons. I'm just using this one knob over here, and I'm using this knob to move the circle that I have on the screen. Really basic. I just wanted to show you the functionality here. Now, what's interesting about this is that if you look over here, you can see that I have connected all the wires together. How does that work? You have the I2C lines coming in here, and then the I2C lines also go into the controller. These are the exact same wires going to both devices, and they are working simultaneously, as you can see over here. I'm moving the circle. That is the beauty of I2C. I2C started in consumer devices like in TV sets, where there is a chip that reads the inputs from the buttons in front of your TV. And then when you press the button, the processor through I2C can detect these buttons being pressed. And then over I2C, the same bus can talk to, let's say, a chip that controls the volume level on your TV set. Now, I2C is more common nowadays, and I see it more used in different areas. It's really low speed, so it's not a thing that you can use in anything that you require speed. But for simple things like of course, when I say low speed, we are now in an age where we're talking about gigahertz. So low speed, it's still pretty quick. But it's compared to CAN bus, for example, it's a lot slower than CAN. But for most things that I2C intended to be used in, it works quite well. Now, how does that actually work? On I2C, there are two sets of wires, data and clock. Clock is always controlled by the master. The master is the processor. In this case, it's the Fez Cobra. That is the processor that is controlling the clock and talking to the individual slaves. You can have standard I2C is 7-bit address. There's an extended addressing, but we don't want to get into that today. So there's a 7-bit address, so you have up to 127 devices that you can have connected. Each slave has to have its own unique address. So when the masters start talking on the bus, all slaves will be not doing anything on power up, not touching the wires, not sending, not receiving, doing nothing. And then the master will start by sending the first byte, and the first byte includes the first 7 bits. The byte has 8 bits, of course. So the first 7 bits is the address. And then the last bit is basically read or write, depending on if it's 1 or 0. So on power up over here, the first thing the code is doing is, let's say, initializing the display. So the processor will send the address of the display with the write bit saying, okay, I'm going to write, and then it sends data, and that data would be whatever data is needed for that specific device, and over here I'm initializing the display. Then later on, we need to read the joystick. Same thing, we would send the joystick address, in this case, the 7-bit, and then instead of a write bit, it's a read bit. And then after that, the master will continue clocking the bus, and then the slave will start sending back the data on the data line. to connect these controllers, because this is not like a standard connector. There is a like a small circuit that just goes inside and end up touching those the pads on the inside. And then from there you can connect the wires. You can also cut the cable and wire it up, but I would recommend you get one of these. You could probably pick it up for $1, including shipping, off eBay. And I think you would find use for these. So give it a try. Let us know what you think. We'll see you next week.